Alright, in this video we're going to continue our review of logarithms for our Unit 7 review, and we're going to practice expanding and condensing logarithms using the properties of logs. So in question 4, part A, I'm going to need to expand this expression. It does say to evaluate the logarithm where possible, and we can evaluate a log that has a number in it, especially if it gives us a whole number answer. That's what we're looking for there. So let's go ahead and take a look at this logarithm here. Because I have three different terms in this log, I have z, x, and y, I'm going to end up with three separate logs once I've expanded. Here's a log, here's a log, and here's a log. And they're going to be filled with all of the guts, the z, the x, and the y from my original log base 2. Now they're all going to share the same base 2, so base 2, and base 2. All I have to do is fill them up with the terms from my original log and decide what sign they're going to be. Anything from the numerator will become positive. So this is going to be that z to the fourth, and it's positive. So I don't have to put a sign in front of this log, because if I leave it blank, we'll assume that it's a positive log. Anything from the denominator, down here, will end up in a negative log. So I'm going to have to make this log negative and put my x inside, and this log will have to be negative, and we'll put my y cubed inside. Now the very last thing I have to do is use my power property to move my exponents to the front. That's the very last part of expanding my logarithms. I end up with 4 log base 2 of z minus log base 2 of x minus 3 log base 2 of y. And that problem's all done. Let's go ahead and try expanding the next one. So up next I have log base 5 of 2a squared b. Inside this logarithm I again have three terms. They may be a little harder to see. Here's a 2, a, and b. So again we are going to have three separate logarithms here. So I've got log, log, and log. They're all going to have the same base as the original, so that's going to be base 5. And all I have to do is fill them up with what I had before and figure out what signs we're going to have. So all three of these, 2a squared and b, they're all being multiplied together, so all of my logs here are going to be positive. They're all going to be added together. And I'm going to fill the first one up with the 2, the next one with a squared, and the last one with b. All I have to do now is finish using my power property to move this exponent to the front, and I'm all done. So log base 5 of 2 plus 2 log base 5 of a plus log base 5 of b. Now it does say evaluate where possible, so I could take a look at this log and see if it can be evaluated, but there's no exponent that I know of that I can raise 5 to turn it into the number 2, so this log is not going to have a nice whole number value, so we're actually going to skip evaluating it until it specifically tells us to get an answer to round to a certain number of decimal places. There's really nothing else we're going to do for this problem. So B is finished. Let's take a look at C. For question C, I have log of 100x squared. I'm going to start the same way I started before. I'm going to look at my terms. I have a coefficient and an x, so this is going to separate out into two separate logs. I'm going to have this log here and here. They're both going to have the same base as the original, and it wasn't written, so there's an invisible base 10 on both of these logs. And I can fill them up with the terms from the original. So this is log of 100, and this is log of x squared. Now they were both being multiplied together. There are no denominators, so they're both positive, which is good. And now I would be done, except I can evaluate where possible. This is the log of 100. The log of 100, this is the little invisible base 10. This is asking 10 to what power equals 100? And the answer to that is that it has to be 10 squared. So log base 10 of 100 actually equals the number 2. 2 plus the log of x squared. So this is almost done. All I have to do now is use my power property to move this 2 to the front of the log, and I'm all finished. You could do this logarithm here in the calculator if you wanted to. Oops, let me put my 2 in front there. So you could do this logarithm in the calculator if you wanted to. Another way that you can look at it, this is actually the log base 10 of 10 squared, and we could move this exponent to the front of the logarithm to log base 10 of 10, and we talked about it in class. If we have the same base and input, this log just equals 1. So this is 2 times 1, which again is that number 2. So either way, you end up with the same value for that logarithm. All right, we just have one more to take a look at, this guy right here, and it's going to work very similarly to question C. So let's split up our log. We have a coefficient 1000, we have an x and a y. What I'm going to do is I'm going to distribute my exponent 3. There are lots and lots and lots of different ways to solve this problem. You could move the 3 to the front first, or you can distribute the 3 inside. It's really up to you. I'm going to go ahead and distribute the 3. It doesn't make a difference. X cubed, y cubed. And now I can separate out my log of 1000 plus my log of x cubed plus my log of y cubed. They're all being multiplied, so they're all going to be positive. Now again, I can evaluate where possible. This is asking me 10 to what power equals 1000? And the answer to that is 10 cubed. So log of 1000 is actually the number 3. And before I finish the rest of these guys, I can move these exponents down to the front. So plus 3 log of x and plus 3 log of y. So log of 1000 actually equals the number 3, and we add it to our other logarithms. Okay, so that's it for expanding our logarithms. I'm going to go ahead and move on to question 5, which is all about condensing logarithms. So use the properties of logs to simplify. Let's take a look at 5a. We're going to try and condense these logs into one giant log. Before I do that, I'm going to go ahead and condense the logs in of themselves as much as I can. So I'm going to go ahead and take a look at that power property that says that if I've got this 9 in front, it can be moved back to the x as an exponent. The same thing with this 3. It can be moved back to the exponent of this y. So this is actually log base 2 of x to the 9th minus log base 2 of y cubed. Now that I've made those exponents again, I will smush these into one giant log. It'll be base 2, and I'm going to fill it up with everything from before. Anything that was positive will end up in the numerator. Anything that was negative will end up in the denominator. And that's it. That problem's all done. Let's go ahead and try example B. Again, same thing. I'm going to start by condensing my logs on their own. So I'm going to use that power property to turn my coefficients back into exponents. So this is log base 5 of a squared minus log base 5 of b to the 4th, and the c doesn't have an exponent because it didn't have a coefficient. Now that I've done that, I'm going to smush them into one giant log, base 5, and I'm going to fill it up with the stuff from before. So remember, any positive log, that term will go to the numerator. So that one was positive. This one over here is also positive, so that will also go in the numerator. Any negative log, like this guy, will end up in the denominator, b to the 4th. And that's it. That problem's all finished. Up next, we're going to talk about solving, and we're going to pick that up in the next video.